Have you ever wondered how logging and monitoring works in Kubernetes? Well, you're not alone. Kubernetes, an open-source platform designed to automate deploying, scaling, and operating application containers, is a complex system. It's like a city bustling with activity where apps are the citizens, and Kubernetes is the infrastructure that keeps everything running smoothly. Now imagine if you could peek under the hood of this city. You'd see countless interactions, transactions, and operations happening every second. That's where logging and monitoring come in. They act like our eyes and ears, giving us insights into the city's health, performance, and potential issues. Just as city officials need to keep an eye on the infrastructure for smooth operations, system administrators need efficient logging and monitoring to maintain the health and performance of a Kubernetes cluster. It helps in detecting issues early, fixing them quickly, and ensuring that the system runs at its best. So, how does Kubernetes make this possible? Let's find out in our next segment. Kubernetes, by default, doesn't have a native storage solution for log data. So, how does Kubernetes handle logging? Let's delve into it. At the node level, Kubernetes deals with logging in a rather straightforward manner. Logs are typically stored in a file inside a container. This means that when you want to access these logs, you're not directly interacting with Kubernetes. Instead, you're interfacing with the container runtime, be it Docker, containered, or any other. Now, it's important to note that these logs are ephemeral, meaning they exist only as long as the container is running. Once the container is terminated, poof, the logs are gone. This is where the concept of cluster-level logging comes in. Cluster-level logging is not a function that Kubernetes provides out of the box. However, it can be implemented with additional tools. For example, you could use Elasticsearch, a popular open-source tool that provides scalable search and analytics through a RESTful interface. Or you could opt for Google Stackdriver, a fully managed service that provides powerful logging, reporting, and diagnostics data. These tools can collect and store logs from your containers, ensuring they're not lost when the container shuts down. This allows you to analyze your logs over time, providing valuable insights into the performance and health of your applications. That's how Kubernetes handles logging. But what about monitoring? Let's dive into that next. Monitoring in Kubernetes serves a crucial role in maintaining the overall health of applications running in the cluster. It's like keeping a close eye on your system's pulse, making sure everything is running smoothly and efficiently. Let's dive a bit deeper into how this works. At the heart of Kubernetes monitoring is the collection of metrics. Metrics are numerical values that provide insights into the performance and health of the system. These could be about CPU usage, memory usage, or even the number of requests handled by a service. Kubernetes collects these metrics in several ways, but primarily, it uses the metrics API. This API is like a trove of information, ready to provide insights into your cluster at any given moment. With it, you can access real-time data about your system's resource consumption, helping you make key decisions about scaling and resource allocation. But Kubernetes doesn't stop there. For those who crave more detailed metrics, there are tools like Prometheus. As an open-source monitoring solution, Prometheus can be integrated with Kubernetes to gather more granular data. It can track everything from the minutiae of individual container performance to the broader trends across all nodes in a cluster. And that's how Kubernetes makes monitoring possible. Now, let's quickly recap what we've learned. So, we've learned that logging and monitoring are fundamental aspects of maintaining a healthy Kubernetes cluster. Let's take a moment to recap. We dived into how Kubernetes deals with logging at the node level, enabling us to troubleshoot problems and ensure optimal performance. We also discovered that Kubernetes isn't limited to node-level logging. With the integration of additional tools, we can extend our reach, allowing us to capture and analyze logs from the entire cluster. Moving on from logging, we delved into the world of Kubernetes monitoring. We learned that Kubernetes utilizes metrics to keep a keen eye on our cluster's health. This system allows us to detect any anomalies or potential issues in real time, leading to faster resolution times and improved system stability. In essence, an efficient logging and monitoring strategy is the backbone of Kubernetes administration. With efficient logging and monitoring, you can ensure your Kubernetes cluster runs smoothly, Thanks for joining us today and stay tuned for more insights into the world of Kubernetes.